So we have an improper integral. First thing we do is turn it into a proper integral with a limit. So limit as b goes to infinity of 0 to b of x e to the minus x over 4 dx. And we need to calculate this antiderivative. This is going to be an integration by parts. So what I'm going to do is I'm going to find the whole antiderivative first, then we'll worry about plugging in the limits. We've seen this form. You should have seen this form in the past. We're going to let u equal x and dv equal e to the minus x over 4 dx. Now this antiderivative, you might decide to use u substitution. Just for time's sake, the antiderivative here is minus 4 e to the minus x over 4. And if you're not sure, you can just check it by taking the derivative. And du is a very simple dx, so we like that. So we have the limit as b goes to infinity. Excuse me, we didn't want that there. Let me rewrite that. Limit as b goes to infinity. And I'll start my antiderivative here. I have uv, which is minus 4x e to the minus x over 4. And that is going to be from 0 to b, minus the integral of v du, minus 4 e to the minus x over 4 dx. And all that, we're going to be taking the limit as b goes to infinity. So, I have the limit as b goes to infinity. Let's go ahead and plug in our limits here. The first part is going to be minus 4b e to the minus b over 4 minus, when I plug in 0, this whole thing is going to zero out. So there's, that first part is right here. That came from that guy. Now here, I'm going to pull out a plus 4. And then I'm just doing the antiderivative that I did before, which I know is right here. So minus 4e to the negative x over 4. And this guy is from 0 to b. So let's see what we have left. We have the limit as b goes to infinity minus 4b e to the minus b over 4 minus 16, and then this is going to be e to the minus b over 4 minus e basically to the 0, but let's just write it out, minus 0 over 4. So I pulled the constant out here and then just did that piece there. So we have a couple parts here that you can see depend on b, namely this guy and this guy. So let's look at those limits. Well, this limit we can see right here is pretty simple. This one goes to 0. This is the limit that gets a little bit interesting, and I'm just going to do kind of a quick version of it because I've done it in other videos. Basically, what we're looking at is a 0 times infinity case. And so if we do that off to the side here, let's just do it down here. We got the limit as b goes to infinity. I'm going to simplify it just a little bit. If we're doing b e to the minus b, this is a 0 times infinity case, which makes it a L'Hopital's. So what we're going to do is we're going to rewrite it as b over e to the b, which now makes it an infinity over infinity case. So applying L'Hopital's rule, remember that means you take the derivative of the top and bottom separately. Well, the derivative of the top with respect to b is just 1. The derivative of the bottom with respect to b is just e to the b. We have a denominator that's going to go to infinity and a numerator that's going to stay at 1. We can now see that's going to go to 0. So this limit will also go to 0. So, just a quick explanation of why that happens. What do we have left? So the limits are done. We have a negative 16, and careful, this is not 0, that's a negative 1. And so we get that this thing converges to 16.